So welcome to Mathematics. Today we are on the 2021 Universal Floral Integration Bee qualifying round. This will be focusing on part 1, looking at the 6 first problems. And so problem number 1, the indefinite integral of 1 over square root of e to the x minus 1. Problem number 2, which was the indefinite integral of 2021 times x times sine of x squared. Problem number 3 is the indefinite integral of the natural logarithm of x over x squared. Problem number 4 happens to be 1 over negative x to the power negative 1 plus x to the power negative 2 minus x to the power negative 3 plus, and so on and so on. And then problem number 5 happened to be the indefinite integral of 1 over x squared plus 25 all to the power 3 over 2. And problem number 6 happened to be the definite integral from x equals to 0 to x equals 3 of x times the absolute value of x times the ceiling of x times the square root of the floor of x. So those are the 6 problems we'll be focused on today. We'll go step by step and see how we can solve these problems. So without much ado, let's jump onto the solution phase of this video. So on to problem number 1, the indefinite integral of 1 over square root of e to the x minus 1. I think what we're going to do here is we're going to provide 2 ways of solving this problem. Let's begin with the first one. So this could be equated to, what I can do is, since we have 1 at the top, I can pull e to the x out so that we have e to the x over 2 times square root of 1 minus e to the power negative x. And this eventually is the integral of 1 over square root of 1 minus e to the negative x, e to the power negative x over 2 dx. So the next thing we're going to do is we're going to have to substitute for this part here. And how we're going to do is we're going to say that let u be equal to e to the power negative x over 2 such that du dx is equal to negative a half e to the power negative x over 2, and that means that negative 2 du can be used to substitute for e to the x over 2 dx. So this part here has some relationship with that, right? So the next thing is, in the u domain, our problem becomes, from here we have 1 over integral of 1 over square root of 1 minus u squared, because e to the power negative x over 2 is the same, squared is the same as e to the power negative x. And then in place of this part here, we have now negative 2 du, which is the same as negative 2 1 over square root of 1 minus u squared du. Next thing we would say, let u be equal to cosine of t such that du dt is equal to negative sine of t, and therefore du can be used to substitute for, or negative du can be used to substitute for sine positive sine t dt. So this and this can be substituted off with positive sine t dt. So our problem in the t domain becomes 2 sine t dt over 1 minus cosine squared t, which is the same as 2 sine t over sine t, 1 minus cosine squared t, square root is sine t and so we have 2 the integral of 1, which is the same as 2t plus c. Okay, but since cosine of t was equated to u, that means that t is equals to arc cosine of u. Therefore, our solution temporarily is plus c, but u was, and so the final integral of our problem is equals to 2 arc cosine of e to the x over 2 plus the integration constant c. So that is one version of the solution. We're still going to continue to share the other version of the solution. So method 2, we're trying to solve this integral. We could try to substitute for this part here by saying that let u be equal to e to the x, square root of e to the x minus 1, and so u squared is ex, and therefore 2u du dx is equals to e to the x, meaning that you could substitute for 2u, you could substitute for e to the x dx with 2u du. And so this problem of ours can be now rewritten as e to the x dx over e to the x. And from here we see that e to the x is equal to u squared plus 1, right? Very important part. So we have, this is u, so we have 1 over u. E to the x dx is the same as 2u du. E to the x is the same as u squared plus 1. So we have that. And so our problem is twice the integral of 1 over u squared plus 1. And this is a famous integral. I won't labor to show the solution to that, but the integral of, let's just write it down, 1 over x squared plus 1 integrated is arctangent of x plus c. So this here is a famous integral, and so we're just going to borrow from that, and so what u is, since u is equals to square root of e to the x minus 1, our integral is now 2 arctangent of square root of e to the x minus 1 plus the integration constant. And that is our solution. So we've shown 2 ways of doing it. The expression that we showed previously was twice the arctangent of negative of e to the power negative x over 2. You could play around and still come back to a similar expression there. Okay, so let's move on to problem number 2. So problem number 2 just happens to be an indefinite integral of 2021 x sine x squared, And we could try and substitute for that by just saying let u be equal to x squared, meaning that du dx is equals to 2x, and so du can be used to substitute for twice x dx. So we can rewrite our problem here as 2021 over 2 sine of x squared 2x dx, and so this part here can be substituted, and also this part can be substituted, so we have 2021 over 2 sine of u. Okay, so this is a very simple integral, so this is the same as negative 2021 over 2 cosine of u plus c, and so we know since u is equals to x squared, our problem 2021 x sine of x squared is equal to negative 2021 over 2 cosine of x squared plus c, and that is how we would solve it. As simple as that. So problem number 3, the indefinite integral of natural logarithm of x over x squared. Just as a by the way, natural logarithm of x is the same as log to the base of e of x. So this is just a by the way. We're going to use here integration by parts. So this problem can also be expressed as the indefinite integral of the natural logarithm of x times the derivative of negative 1 over x, right? And so using this formulation where if you have a product of function u and the derivative of function v, that integrated, that's the same as uv minus v times the derivative of u. Now the derivative of v, so function v can be taken as negative 1 over x, function u can be taken to be a natural logarithm of x. That means that now uv is the same as negative natural logarithm of x times 1 over x, so over x, and then minus, since v is negative 1 over x, right, the derivative of natural logarithm of x is the same as 1 over x. Okay, so this negative and this negative will interact, so we have plus 1 over x squared, and so our problem here is the same as negative natural logarithm of x over x minus 1 over x plus the integration constant. The integration of 1 over x squared is negative 1 over x, and that is our solution. So problem number 4, the indefinite integral of 1 over negative x to the power negative 1 plus x to the power negative 2 minus x to the power negative 3 plus and so on and so on. This, we can express this as something like this. Negative 1 over x plus negative 1 over x, so this is the power 1, this is the power 2, plus negative 1 over x to the power 3, and so on and so on. So we have a geometric progression with a common ratio being equal to negative 1 over x, and then the first value is equal to negative 1 over x, right? The first value here. And so that summation where you have something from, let's say, k equals to 1 to infinity of r to the k. This is the same as r1 minus r. Okay, so using this formula, we are going to now come to the integral of 1 over negative 1 over x over 1 plus 1 over x. So this is the same as, pull the negative out, we have x, 1 over 1 over x is x times, so since we have 1 over x over x plus 1, so that and that cancels, so we get the integral negative x plus 1 dx. So negative there is important, and so our integral of 1 over negative x to the negative 1 plus x to the power negative 2 minus x to the power negative 3 plus and so on is equal to negative x squared over 2 plus x plus integration constant c. And that is our solution. So problem number 5, 1 over open bracket x squared plus 25, the power 3 over 2, integrated. We could begin by substituting by saying let x be equal to 5 tangent theta such that dx d theta is equals to 5 sec squared theta, right? And so what happens here is that dx can be substituted off by 5 sec squared theta d theta. And so our integral now becomes indefinite integral of 1 over open bracket 5 squared tan squared theta plus 25 to the power 3 over 2 dx is the same as 5 sec squared theta d theta. And so this 5 squared is the same as 25. We can pull that 25 out. So we have 1 over 25, 3 over 2. We have tan squared theta plus 1, 5 squared theta d theta. This is 3 over 2. So this is the same as 125, so we have over 125, and then this is the same as 1 over sec squared tan squared theta plus 1 is the same as sec squared theta, so we have sec squared theta to the power 3 over 2, 5 sec squared theta. Yeah, and this becomes 25, and here we get sec to the power 3, so we have in essence 1 over 25 sec squared theta over sec cubed theta. This is the same as 1 over 25 1 over sec theta, which is 1 over 25 cosine theta integrated. So since we've come to cosine theta, this is the same as 1 over 25 sine theta plus c. But we said let x be equal to 5 tangent theta, so x over 5 is equal to tangent theta. And so if we have a triangle there, theta with the base angle theta. Since tangent is the same as opposite over adjacent, so we're going to have x over 5, and the hypotenuse becomes x squared plus 25. And therefore, sine theta becomes opposite, which is x over x plus 25. Right? So, in other words, our problem, 1 over x squared plus 25 to the power 3 over 2 becomes 1 over 25 x over square root of x squared plus 25 plus c. And that is our answer. Okay. So the next problem number 6, which is the definite integral from x equals 0 to x equals to 3 of x times the absolute value of x plus times the ceiling of x times the square root of the floor of x. So a couple of things we need to know is what is the absolute value of x, what is the ceiling of x, what is the floor of x. So the absolute value of x means that it equals to a couple of things. It is negative x when x is less than 0. It is x when x is greater or equal to 0. And then the ceiling of x is equals to let's see, is equals to k plus 1 when x is greater than k, less or equal to k plus 1. Okay, the floor of x is equal to k when x is greater or equal to k but less than k plus 1. Okay, where k are integers. So that when we have our graph plotted like that, from 0, 1, 2, and 3, since x is greater than 0, it means, or equal to 0, it means that the absolute value of x is going to be equal to x. So our problem here just becomes x squared ceiling of x square root of the floor of x. So we're going to do color coding now. So for x squared, we have 1, 2, 3. We're going to have something like that. That is x squared. For the ceiling of, in other words, this part or this part, from 0 to 1, at 0 we have, and then we have that all the way up to here. Then between here we have 2 up to that, and then from, so here we have 3 up to 3. So this is the ceiling of x. And then the floor of x, we're going to here, sorry, and let's delete this. Oops. Well, write that again, but for now let's do that. And then from 2 to 3, so this is what we call the flow of x. And we by mistake deleted, sorry, this is supposed to go all the way up, sorry, x squared. Anyway, so that's the idea, and this is 1, 2, 3. So what our problem becomes essentially is that we're going to break it down from 0 to 1, and so we have x squared. The ceiling there is 1, the floor there is a square root, so the floor is 0, so square root of 0, plus 2, 1, 2, 3, 2 rather, we have x squared, the ceiling is 2, times the square root of 1, plus from 2 to 3, x squared, ceiling is 3, and then square root of the floor, which is 2. So, which is 0, 1, x squared times 0, plus 2, x squared, 1 to 2, plus 3 root 2 from 2 to 3, like that. So this goes to 0, and then we are left with this 2. So we see that we have 2 times the integral from, rather 1, 1 to 2 of x squared, plus 3 root 2 integral from 2 to 3 of x squared. So this becomes 2 x cubed over 3, 1 to 2, plus 3 root 2 x cubed over 3 from 2 to 3. So this is 2 times 8 minus 1 plus root 2, 27 minus 8. Okay, so this is 14 plus 19 root 2. So the integral from 0 to 3 of x times the absolute value of x times the ceiling of x times the square root of the floor of x is equal to 14. Sorry, we forgot 3 here, 14 over 3, no, that's that guy there, plus 19 root 2. That's the answer. Okay, so thank you so much for hanging out with us. This is how you may have solved the problems that we shared with you. If you have any questions regarding any of the steps that we undertook, please reach out to us via the comment section, or you can email us directly. But it's been an absolute fun hanging out with you. Until next time, bye bye.